Assalamualaikum and hi everyone. Topic 10, Application of Differentiation, Lecture 2 of 3, Part 1 of 6. At the end of the lesson, students should be able to A. Solve optimization problems. Optimum problems. Now we continue example 1. An open top box is to be made by cutting small congruent squares from the corners of a 12 cm by 12 cm sheet of tins and bending up the side. The question: how large should the squares cut from the corner be to make the box whole as much as possible? Okay, so firstly you need to understand what is the information given here, and secondly you need to understand what is the question asked here. Okay, firstly you need to understand that we want to create an open top box by cutting the small congruent square at a corner, okay, and we will binding up the side. So the question said, how large should the square cut from the corner to make the box whole as much as possible? Okay, so from the question here, we have a clue here, means the question asks how large should the square cut, means the question asks what is the value of x to be cut from the corner for the box to hold as much as possible. Hold as much as possible here means the volume. Okay, V stand for the volume. So to get the volume maximum, okay, I write here maximum volume, the volume is maximum. So what is the side to be cut? Okay, to solve this problem you should understand that we will use the second derivative test to solve the optimization problems here. Okay, so to solve this you need to understand what is the function that we want to optimize here. Okay, so the question asks what is the value of x to be cut at a corner to get the maximum volume. Okay, so to get the maximum volume means you have to create what is the function of volumes in terms of x, because you need to find what is the value of x to get the maximum volume. So you have to create what is the function of v in terms of x. Okay, so you have to imagine that when you cut the corner you will get the box like this, and the length of the box is 12 minus 2x. This one also 12 minus 2x, and the height of the box is x. So the volume for the box is x. You have to multiply with 12 minus 2x and we have squared there. Okay, this is the formula for a box, the volume for the box. So we expand to get x multiplied with 144 minus 28x plus 4x squared, and you multiply x Inside you will get 144x minus 48x squared plus 4x cubed. Okay, this is the simplest form of the formula. So the formula now, the volume now is ready to be differentiated. Okay, now we will differentiate dv dx. You will get 144 minus 96x plus 12x squared. Remember, we want to find the maximum volume. To get the maximum volume, you need to differentiate and you have to equals to 0. So dv dx must equals to 0 to get the maximum volume. Therefore, 144 minus 96x plus 12x squared equals to 0. Then you can factorize. You will get 12 minus 8x plus x squared equals to 0. Then you will get 12 x squared minus 8x plus 12 equal to 0. Therefore 12x, you have to minus 6 and another one, x is minus 2 equals to 0. Therefore you will get x equals to 6 and x equals to 2. Okay, this is the two values of x that we are going to substitute into second derivative of v. Okay, now we continue to do the second derivative for v, that is d squared v dx squared is equals to negative 96 plus 24x. Okay, then what should we do now? We will substitute x equals to 2 and x equals to 6 into d squared v dx squared, and we have to check which one will give the value for d squared v dx squared the negative value. That is, the value should be less than 1 to get the maximum volume. Okay, firstly we substitute x equal to 2. So d squared v dx squared, when you substitute x equal to 2, you will get negative 96 plus 24 times 2, and the answer is negative 48. Negative 48 is less than 0, a negative value. So this means that you will get the maximum, or the volume is maximum or minimum. The volume is maximum. Okay, when you get the volume is maximum, when you substitute x equal to 2, you don't have to substitute x equals to 6 here. Okay, you don't have to substitute x equal to 6. So we already get the answer. So therefore the conclusion is, when x equals to 2, the maximum volume is or equal to x multiply with 12 minus 2x squared. Means you have to substitute 2 times 12 minus 2 times 2, 4 squared. And the answer is 128, and the unit is centimeter cube, because we are talking about volume now. Okay, so this is the answer. The maximum volume is 128 centimeter cube when x equals to 2. Okay, when x equals to 2 centimeter. Okay, thank you.